Okay, so the first question of the midterm exam was related to making a sheet metal design for a bracket according to the drawing that has been shared, and we would like to create this based on a metal properties that is given in the exam, and starting with the base flange sketch and create some other information that based on the information that is given here. Okay. So the design that is given for this metal bracket is as following. So essentially it says that let's start by the base flange that is given here. So it's better that we create this sketch and follow along the process. So as you see, this sketch is symmetric along the vertical axis here, so we can create right around this one. Um, so let's start a new part, and we are going to select the plane and start a sketch there. Okay, so I would start from front plane and create a sketch there. Go to center line and create a vertical center line, which would be my axis for mirroring later down the road. So the sketch showing that here I can create a like an arc. What I can do, I can create a circle right around here or the other way. So let's create a circle and going through a line that passing through this, coming all the way here, and with this shape around here. So I know that I can trim my entities for the areas that I don't want it, which would be here, here. Hold on. Maybe maybe it is better that instead of creating a sketch here, create a vertical sketch. So it's gonna help me in the trimming. So I'm gonna trim this area and this area. Yeah, that's better. So let's go back to the dimension that is given. We know that this should be mmgs for that because everything is based on a millimeter here. So first the angle between here and the mirror is that. So first we know that this is r is 20. So this would be r equal 20. You can go ahead and mirror it at this point and then add dimension. That's another way. So I'm gonna add this dimension and hold control this one. Or you can say mirror entities, mirror this line, and this arc, and mirror and copy with respect to this vertical line here. Yeah. What other dimension is given? The angle between them is 90 degrees between this line. So here, while you're in the small dimension, and here would be 90 degrees. Other dimension is the horizontal distance between the two ends is 100. So this distance and this distance in this 2 point is 100. And we know we have to add as much dimension as possible to make the sketch is fully defined. So you know that this is kind of flipped here, so we can drag it to bring it in the shape that I want it. The other dimension is that length is 10 in either side, but I only need to dimension 1 because this is a mirrored sketch. So last one is 10. So it seems like there is only one dimension that is not given here. So we add that 100, 10. Sounds like everything is defined. Let's see what is not defined here, which is if I drag one of them is right around here. Oh yeah. So we know that this line should be coincident with this line. select this line, select the center, and make them a coincident. With that addition, this sketch is now fully defined, and I can exit out of the sketch. So I have this sketch, and I know that based on the information that is given here, it says start with the base flange sketch. So this is the base flange sketch here. How much is going to extend it? Let's find out how much this sketch is going to be extended along this one. To do that, which appear from here, this would be 70. So that is 70. That is going to be, this flange is going to extend it. So while the sketch is selected, I'm going to go to sheet metal and select the base sketch. Here I have to define some direction. So in direction 1, I selected a mid plane because I want to keep it symmetric and make it 70 millimeter. Now I have to define some of the information that is given here. So it's aluminum gauge 14. So go to the gauge table and select aluminum simple table. Okay, once when it is loaded, I'm gonna select gauge 14, which is equivalent to the 2 millimeter thickness that is given here. Bending radius is 2 millimeter, so bending radius is 2 millimeter here. Go by default, K factor 0.5, K factor 0.5. Auto relief rectangular 0.5 millimeter, so its default is tier here. I will change it to rectangular and change it to 0.5. Okay, and then hit OK. This would define the sheet metal for the base that I do have here that I have to essentially work on it. So the second thing that I would like to work on it is these edge flange that I have. And if I go back, if I'm going to look at here, this is the one that I have to pick. So I can create one of these base flanges and essentially mirror that across all edges. Let's go, and in the sheet metal, I would select edge flange, and I would select this area, bring it somewhere here, leave it. It doesn't matter how long you are extruded out, because you are going to go to edit flange profile, and you're going to define it in a way that you would like to have it. Based on what I see here, I have to create a sort of like a hollow here, and then with a curve that I have to put. So first I see that in order to do that, let's say I'm gonna shift it here, bring it a lot here, arbitrary. You don't need to be it doesn't need to be exact, but I'm gonna pick this one and delete that because I'm gonna replace it with the arc. So I select the tangent arc, start from one end and go all the way to the other end. And here I'm gonna add another hole in the center. Now let's define what parameters it has. So the big radius here is 10. So go here, smart dimension, and this should be 10. While other dimension is the distance from this edge is 20, and this is like a internal edge. So distance from here to here is 20. And then it says that this horizontal to this edge is the vertical distance from the hole is 12. So from here all the way to here is 12. And the radius is 5 for this one. Take it out and create 5. Now the sketch is fully defined. I'm gonna go back because I have to now define a position of what. So you see that once you define it, you don't need to define a length, but you need to define a flange position. And if I look at, based on the flange position, if I look at this view, I will see that this one is right across this edge. So based on the position of this edge flange and the from this view, I will realize that that should be material outside is the correct flange position. And hit OK. So I have my edge flange here, and you see that the auto relief is exactly rectangular. That is why auto relief type is important. So I'm gonna repeat that along all other edges. So while the edge flange is selected, I can go to features, select a mirror, and I would select based on, for example, front plane. And I'm gonna create this one. Then again, once the mirror is selected, I again select another mirror, and this time I would select right plane to mirror it again. So this way I would have all 4 edge flanges that I have. Okay, we had a good progress here. Now I see that I have 2 ham positions here and here, but maybe it's time that I can create a slot hole that I have here. You can either select either ham or a slot hole, whichever that is easier. Okay, so here's a point that I have to bring it back is the custom relief I had to define for each flange, and it says that the width is 2, the depth is 1. So I have to go back to the edge flange because I have to change to a custom relief. It's not gonna go. So I'm going to custom relief type, select this, and it says rectangular, but I'm not going to use a ratio, default ratio of half, because it says width is going to be 2 and depth is going to be 1. Then it's going to be fixed. This is to make sure that it's exactly according to what I have here. And if you see that, you see that the auto relief has been changed accordingly. So this is done. Let's do ham type. It says ham is closed and the length is 5 millimeter that I have to define. So it should be easy one. So I'm going to sheet metal, select ham, not ham, ham, and I select this edge. I will select the other edge. So the type is closed, which would be this type, and the length is 5 millimeter. Okay. I have my ham here. So I have ham selected, closed, everything is good. The only thing is the slot. So here is an information that is given here. It says the slot holes in the middle of the part shall be done in a flatten mode. Try to unfold the part along the flat face, make a cut, and fold it back. That should be that's exactly what it wants. So we have to first unfold it, and I would select across any flat edge. I would select this face, and I would say let's collect all bends that you can find instead of selecting one at a time, and hit OK. This is gonna flatten my view that I can make a cut. You cannot use a flattened view because this is only for view. It doesn't create any operations in order to cut it. So I have to cut here, select this one, and go to the sketch mode. I have to essentially create a cut in here. The information for the cut is according to here. So first I have to sort of put it exactly in the center point, and then it has a 2 cut that you have to create that. And if you see that this does not fall necessarily in the center of this, so should be easy way. I'm gonna go to the center line and hover around the center point. It's gonna create that, and coming here, this is the center point that I have to create. And one way to create stuff like this is I can go by any other. There's a lot of way to doing that, and one way is I know that this would be along this line as well. So as like a mirror, I create another center point from here to this vertical point. This would be the mirroring tools that I have. So I'm gonna create a line here from here to here, and then I'm gonna select this line and mirror it about this vertical, the horizontal center line, And then I have to create two arc between here, and according to this arc is not tangent. So go to the arc, 3-point arc, and select between here, here, put it here, and then I put it select here, here, put it somewhere. Now going back to dimension, so it says that this is 15, this distance, so this should be 15, and since this is mirrored, the other line would be the same one. This is 12, the distance between them, so here to here is 12. The end point of this edge is 22.5, so this end point to here is 22.5, and the radius of is 7.5 either end, so this is 7.5, this is 7.5, so it's fully defined. I have to mirror this slot sketch with respect to the vertical line. So I'll go to mirror entities, and I would pick all the entities that I would like to mirror, which would be these 4, and mirror about this vertical center line, and hit OK. Now exit out of the sketch. Now I have to cut through this. So while the sketch is selected, I can go to the extrude cut, and I can link to thickness to make sure that the cut through the metal. Hit OK. Now the cut has been selected. After this unfolding, now I have to fold it back. So I fold it again, and it's automatically select the same face that I have been unfolded. Again, collect all the pens and hit OK, and that should goes back to the original shape that it has, which is this. And that you can save it if I want, and that would be my finalized part. Let's review that one more time. Yeah, this view is gonna be a sketchman. This is a slot cut in flat node. Yeah, everything we did was recorded. Thank you.